All right, part 2 of this chapter 3 review. Let's look at number 6 here in this review section. This will be a good one. Travel time to work. The frequency distribution listed in the table represents the travel time to work in minutes for a random sample of 895 U.S. adults. So here we have our classes here on the left-hand side, the travel time with a width of 10, and then our frequencies for each of these different times here on the right-hand side. So the first question, approximate the mean travel time to work. Second question, approximate the standard deviation. This is coming from 3.3. This is where we are estimating the mean and the standard deviation for this grouped data, grouped because it's in these different classes. So we're going to do the calculator thing again. Now you have to be a little bit careful when doing the calculator for this stuff. Can I make this smaller? I guess not. It's okay. Because you cannot plug classes into the table of the calculator. You have to find the midpoints of these classes and plug that in instead. So let's clear out the stuff we were doing before. To clear a column, you want to arrow up to the top of the column and hit the clear button. Do not hit the delete button. Then when you arrow back down, it'll be all cleared. If you hit the delete button, it just deletes the whole column. It's a nightmare. Okay. So let's find the midpoints of these classes. To find the midpoints of the classes, you take whatever the lower limit is of the class, and then the next lower limit, add them together divided by 2. If I take 0 plus 10 added together divided by 2, I get 5. 10 plus 20 added together is 30. 30 divided by 2 is 15. And then you just do that for every single class. You plug in the midpoint of those classes. And then in the right-hand column, the second column here, we're going to plug in the frequencies. So again, I'm going to pause the video and type all this stuff in. All right, so again, the midpoints in the first column, frequencies in the second column. To find the mean and the standard deviation for this grouped data, go back into Stat, arrow over to Calculate. Again, our best friend, the one VAR Stats button. But this time, especially for those of you that have a menu, you have to be a little bit more careful. So with the menu, we do have the list, which is the midpoints for our classes in the first column, but you need to tell the calculator that there are frequencies in the second column. To do that, you have to type the column name into the frequency list. The column name was L2. If you look above the 2 in your calculator, you should see a little L2. So just hit second 2 to type in the frequency list there. Now, if you do not have a menu, you need to do this. So for those of you that do not have a menu, when you first hit that one VAR Stats button, it should show up on your screen like this, and it's just sitting there. Do not hit enter yet. What you need to do here is you need to put L1, and then there's a comma button. The comma button is right above the 7, L2. So this is for people that do not have a menu. Hit the one VAR Stats, it just shows up on your screen. And then L1 comma L2, that tells the calculator that there are frequencies in the second column. So then if we go down to calculate, we get our mean and our standard deviation. So this was just a sample of people that commute. So X bar instead of the mu. Our mean is going to be 27.7. I'm rounding that to 1 decimal point because our data all had whole numbers. And then the standard deviation, I'm going to grab the S because, again, it's a sample, rounded to 1 decimal point, 19.1. Okay, cool. And then that's it. So that's going to be the answer to our question there. Finding the mean for part A, the standard deviation for part B. Moving on. 7, weighted mean stuff. So these are always fun. Let's see if I can, again. Oh, that's not going to work. Oh, it did work. Okay, cool. That way you can see it on both sides here. Okay, so we'll just do one of these. I guess they only give us the one. Let's just do 7 here. Michael has just completed his first semester in college. He earned an A in his 5-hour calculus course, a B in his 4-hour chemistry, an A in his 3-hour speech, a C, and you guys can get the point, right? So this is a weighted mean question whenever you're trying to find GPA. The weighted mean we notate with an X bar sub W. And there's a formula for this. This is one of the few things that you are going to actually have to use the formula for and not your calculator. So for the weighted mean, it is the sum of the data values times their weights, all divided by the sum of the weights. So if you haven't seen that symbol before, that crazy looking E just says to add them all up. Okay, so this is going to be a really big fraction, and we're just going to go down the list. So Michael has just completed his first semester in college. He got an A in his 5-hour calculus course. Go, Michael. Good job. So as far as GPA is concerned, we need to know the data value and the weight. His grade is the value. An A is worth a 4 as far as GPA is concerned. That we're going to multiply times the weight of the course, which is the number of hours of the course, which is 5. So I like to write the data value, X, and the weight above the numbers. So that's his first class. He got an A, which is a 4, times it was a 5-hour course. And then we're adding all of this up, so that plus the next course. His next course, he got a B in his 4-hour chemistry. A B is worth a 3. A 4-hour chemistry has a weight of 4. Plus his next class, he got an A in his 3-hour speech. An A is a 4, 3-hour class. Plus, then he got a C in his 3-hour psychology. A C is a 2. His 3-hour class. Man, he took too many classes. And then it just kind of explains how it goes. I guess he didn't take that many. He took 4. He's good. Okay. So now we're going to multiply these out, add them all together, and we're going to divide that by just adding up the weights. That's why I like to put little X's and W's above these, because it tells me which ones to add at the bottom. We're adding the class hours. He had a 5-hour class, plus a 4-hour class, plus a 3-hour class, plus another 3-hour class. Simplifying all of this down, I'll do the numerator here. I guess I'll do it on the in-screen calculator so you can see how I would do it. I would probably just do this all in one go for the numerator with parentheses. So 4 times 5, close the parentheses, plus the 3 times 4, close, plus the 4 times 3, plus the 2 times 3. I would hit enter here and go ahead and get that number, so 50. And we're going to divide that by just adding up all of the weights, the 5, plus the 4, plus the 3, plus the 3. 15. All right, and then just figure out whatever 50 divided by 15 is. This is GPA, and usually with GPA, we round that to 3 decimal points. So 3.333. Just make sure you're reading the question carefully on where to round GPA stuff. It'll always be specific. Okay, cool. But that's his GPA. Moving on. Question 8 here, another good one. According to the National Center for Health Statistics, the mean weight of a 20 to 29-year-old female is 156.5 pounds with a standard deviation 51.2. The mean weight of a 20 to 29-year-old male is 183.4 pounds with a standard deviation of 40. Who is relatively heavier? A 20 to 29-year-old female who weighs 160 or a 20 to 29-year-old male who weighs 185? Okay, the point of this is that both the female and the male weigh more than their sex's average. But we want to know which one of these individuals weighs more relative to their own gender. To do that, we're going to be finding something called z-scores. And I cannot stress how important a z-score is for the remainder of this class. You're going to see z-scores a lot, but it's going to be a little while. It's not going to be till like chapter 7-ish. The definition for a z-score is going to be the data value minus the mean divided by the standard deviation. It is the number of standard deviations a data value is from the mean. So what we need to do is we need to look at the males and then the females, and then we're going to find the z-score for this particular male and then the z-score for this particular female and compare the two. So for the male, he has a data value of 185. That's going to be minus the mean. The mean for males is here, 183.4. And we're going to divide that by the standard deviation of males, which is 40. For this particular female, she has a data value of 160 minus the mean for females was 156.5. That divided by the standard deviation for females, which is 51.2. All right, so just be careful in the calculator. I'll pull up mine again. So usually what I would do here is I would just do the top part, so 185 minus 183.4. Go ahead and hit enter. And then that's the numerator, that previous answer divided by the denominator 40. So it looks like this male has a z-score of 0.04. We're going to do the same for the female. So her data value minus the mean, just for the numerator there, that fraction. Get the answer to divide that by the 51.2. So this is rounded to 2 decimal places, 0.07. So the question was, which individual, the male or the female given, weighs more relative to their gender? It looks like the female does. So because the female's z-score is a little bit more than the male's z-score, she weighs more relative to their gender. Okay, cool. So that's z-score stuff and how to use that. 9, I remember this question. It's cool to look at. What's important about this question with these box plots is to know what the shape of the distributions are. We're not going to go through the whole thing. But the point of it is, like if you're looking at this one down here, because this one is about the same on both sides, this would be like a bell curve if you were to graph it out in a histogram. Although this one, because this is kind of way stretched out on the left, this is going to be more left skewed. This one looks more right skewed. This one looks left skewed. This one, pretty hard to tell, but because of this whisker out here, I would say left skewed, since it's way out there. Other than that, it's box plot stuff. So make sure you know how to graph a box plot, and you'll be good there. Moving on. Let's see what else we got in this review. Okay, so this one's pretty important here, number 10. But I think I'm going to go into the next video for this one just because there's different questions about it. So I'm going to end this one and I'll make another video just doing number 10 here.